All right, how's it going, team? This is the video for Safety 1 Homework 5. This is the 5th iteration of safety that you've done, pre-occupation safety that you've done. So hopefully this shouldn't take us too long. So we're gonna try to do a bit of a speed run here on Safety 1 Homework 5. But let's go ahead and get started. So compute pre-occupation low and high angle safety for the following range safety card. Okay, so we're gonna do a couple squares here. We're gonna square in, we're gonna solve for both 4 square and 6 square because we're doing pre-occ safety, okay? Firing point 166 in South Carolina impact area. So weapon system, it says 155 millimeter, Mike 109 Alpha 6. We're also gonna square this. We're gonna solve for M777 Alpha 2. Reason we're doing that is so we can get one more rep in at a muzzle velocity correction and a square weight correction for pre-occupation safety, because that's the most difficult thing that we do, which means that's probably the thing that we're going to be evaluated on. All right. So type of fire, both low and high angle. So that tells me I need to calculate a low angle and a high angle safety T. Mike 795 HE, shooting Mike 232 Alpha 1. Those are my hotel charges. 739 Alpha 1 PD, 767 electronic time, 732 Alpha 2 VT fuse set to the even second. All right, left limit 4,300, right limit 5,000. Let's go ahead and find our azimuth of lay. 4,300 plus 5,000 divided by 2 gives us 4,650, which expresses to the nearest even, always to the 100 mils. So azimuth of lay is 4,600. Azimuth of lay is 4,600, okay? Low angle min range 11900. Fuse time and high angle min range 12300. Max range 17200. Shooting charge 4 for the entire safety T. Looks like we have a max range dogleg from azimuth 4,300 to 4,460. Max range is 5,500 meters. I believe that, let's see here. Yeah, so that's an error we need to square in. Yep, good thing we caught this. We need to square that in. That should be 15500. So that should be 15500 instead of 5,500 meters, okay? Yeah, we wouldn't be able to shoot for hotel at range 5,500. So that should be 15500 meters. So that's gonna be our square. All right, so survey data, battery altitude is 376.5, which expresses to 376. Okay, then coming down here, so range, 11900, that is min range, max altitude. 12300, that is min range, max altitude. 15500, that's max range, min altitude. 17200, that's max range, min altitude. Range, safety card, complete. So let's move on to our low angle. Let's move on to our low angle safety computation worksheet. Where are you at? There you are. All right. So low angle safety. Let's start off with location. We are at firing point 166 at 53093435. Battery altitude was 376 at charge 4 hotel, specifically 232 Alpha 1. Fuse PD time VT. You can put the nomenclature here, it doesn't really matter. Azimuth of lay we said was 4,600. So azimuth of lay 4,600. Now that we have that, let's get our straight edge. Let's get our straight edge and start constructing our basic safety diagram. So I know that I have one overall minimum range, so let's go ahead and record that. So that is range 11900. And we said, it's 11900, and we said that the min altitude, or correction, max altitude is 440. Okay. So we have what looks to be a left side dog leg. Probably didn't leave myself enough room like I always do. Okay. So let's see, min time, range line. Min time range line was 12300. Yep. Okay, dog leg here, range 15,500, altitude 15,500, altitude 400. Overall max range, said was 17,200, altitude 420. Okay, now we have that. Let's go ahead and label our azimuths. So starting from the left, overall left limit azimuth 4,300. We know we're going to have to turn that into a deflection. Okay, next one, so from 4,300 to 4,460, so that's azimuth 4,460, and then overall right limit is azimuth 5,000. That we're going to have to convert both of those into deflections. All right, now that we have that, go and draw our arrows. So to get from azimuth of fire 4,600 to my overall left limit of 4,300, what do I have to do? I have to go left, how many mils? I have to go left 300 mils. Okay, to get from 4,600 to azimuth 4,460, what do I have to do? I have to go left 140 mils. And to get from azimuth 4,600 to my right limit, what do I have to do? I have to go right 400 mils. All right, so now that we have that, let's convert that to deflection. So now we're talking deflection, so LARS, left add, right subtract. So deflection 3,200, going left 300, so left add, so that turns to deflection 3,500. And I know I'm gonna have to add my drift here in a bit. Okay, so deflection 3,200, left 140, so that's adding 140 to 3,200. What does that give us? That gives us 3,340. We're gonna add our drift here in a bit. I never give myself enough room here. Okay, and then on the right, so deflection 3,200, right 400, so left add, right subtract. That gives us deflection 2,800, and then we're gonna have to add our drift here in a bit. Okay, all right, so basic safety diagram is complete. I can put this away for now. Let's go ahead and fill in our admin data before we start this stuff down here. So charge for hotel, specifically 232 Alpha 1, shell HE, fuse PD, time VT. Projectile family Mike 795, machines are going to be in the Alpha Romeo 2. Okay, so do we have a muzzle velocity correction? Let's go ahead and find out. So extract our AR2, refer to Roman numeral page 9, and what do we have for 232 Alpha 1 charge 4? Yes, we do. We have a an increase in 4.0 meters per second for an M777. Remember, because the TFT is based off the Paladin, so I have to account for a range correction for a positive 4.0 meter per second change in muzzle velocity. Okay, and that's going to apply to all of my ranges. So diagram ranges, go ahead and list them out. 1,900, 1,2,300, 1,5,500. And 1,7,200. Okay, so that's at charge for hotel, 232 Alpha 1, and that applies to everybody. Non-standard condition, right? So the non-standard condition is an increase, or positive 4.0 meters per second, right? And I'm getting that from the far right-hand column here in Roman numeral page 9. Remember, we don't really care about, I'm just gonna go ahead and mark this out real quick. We don't care about the 198, right? Because we don't shoot that anymore. We have some partners in the Middle East that still shoot Mike 198s that we gave to them, but we don't shoot those. And then the Mike 109 Alpha 1, we don't shoot that anymore either, right? That's like Vietnam era Paladin. Okay, so all we care about here is the M777 Alpha 2. Okay, so now that we have that, so minus the standard condition, what is the standard condition? Standard condition is 0 meters per second, right? Standard condition is for the Paladin. Gives us an increase of 4 meters per second, and that applies to everyone, right? So an increase of 4 meters per second. Now we need to find the diagram range correction. So we find that in table Fox. Okay, so let's see here. So charge 4, making sure that we are in 232 Alpha 1 up here, right? Always check to make sure you're in the Alpha 1 table. All right, so first things first, let's find 11900 Making sure I'm low angle. 11900. Okay, so increase gives me a value of negative 28.1. Correction, negative 21.8. Negative 21.8. And I'm here on page 413 of the Alfa Romeo 2. All right, next I have diagram range 12300. So 12300 gives me a value of negative 22.2. Next I have 15500. Turn the page here to page 415. Gives me a value of negative 25.3. And then 17200 gives me negative 26.9. All right, I like to extract my data before I start doing the math. Let's put that aside. Let's start doing the math. So I take this value here, so my change in standard, which is 4, increase of 4, multiplied times my diagram range correction. Okay, and the reason I had to extract it from column 1-1 is because it is an increase of 4 meters per second. Okay, so that's 4 times 21.8 gives us 87.2, specifically negative 87.2. Always record the raw number that comes out of your calculator and then express it to the nearest 10 meters. So that's negative 90. Okay, now 4 times negative 22.2 gives us 4 multiplied times 22.2 gives us negative 88.8, which expresses to negative 90. Next is 4 times 25.3, which gives us negative 101.2, which expresses to negative 100. And then 4 times 26.9, which gives us negative 107.6, which then expresses to negative 110. All right, so now that I have my total range corrections, I can start calculating my entry ranges. So diagram range, first one is diagram range 11900. That's a min range line, okay? Do I have a range correction? Yes, I do. So plus minus 90 gives me a total range correction of, let's see here, 11900 minus 90 gives me a total range correction of 11810. Multiplied times range K of 1.0000 gives me entry range of 11810 at charge for hotel alpha 1. Okay, and that's going to apply to everybody as well as that range K, so I'm just going to carry that down. Okay, so next is my min range of 12300. That's my min time range line. All right, do I have a range correction? Yes, I do. Plus negative 90 gives me total range 12300 minus 90 gives me total range correction of 12210. Turn the music up just a little bit. 12210. Okay, multiplied times my range K gives me entry range of 12210 at charge 4. All right, next I have my first dog leg, or I have my max range dog leg, 15500. Okay, and I do have a range correction of negative 100 meters. 15500 minus 100 meters gives me a total range of 15400. Multiplied times range K gives me 15400 as my entry range. Then finally have my overall max range of 17200. Range correction of minus 110 gives me 17200. 17200 minus 110 gives me 17090 as my total range. Multiplied times range K gives me entry range of 17090. All right, so now that I have all my entry ranges, I have my charge, I can go ahead and start finding my site. I know I'm not going to need site for range 12300, but we'll get there here in a minute. All right, so first things first, for min range 11900, let's find our VI. VI is target altitude, so target 440 minus battery altitude of 376 gives me a VI of positive 64. Okay, let's go ahead and find all of our VIs. So 15,500, let's see here, target, which is 400 minus battery of 376, gives us a VI of positive 24. Okay, positive 24. And then finally, 17,200 is target, which is 420 minus 376, gives us a VI of positive 44. Okay, now we need to solve for our site. Now, something to keep in mind for higher charges, for like charge 4 and 5, almost all of the ranges will almost always be above 10,000. So I need to remember that I'm going to use my my rough math rule, right? Okay, so let's go ahead and do this first one. So VI, so for range 11900, VI of positive 64. Ensuring that I'm using the 232 alpha 1 GST right here, right? Not just the 232, but the 232 alpha 1. If I use 232, my site is going to be wrong. Okay, so VI of positive 64. Target above gun at diagram range 11900. Let's see here, where are you at? So that's 100, it's 5. Six, 7, 8, 9. All right, 100. So that's target above gun, charge 4 at range, what do we say? 11900 with a VI of 64. No, the manufacturer hairline moved. 61, 62, 63. Especially with these higher charges, you gotta give it a second look just to make sure that everything is aligned properly, okay? Let's go and extract our 3 numbers. I see, let's see, that's 5, 6, 6 in my 3 numbers. 5, 6, 6. Okay, so this is for site at range 11900. Our 3 numbers we extracted were 5, 6, 6. Okay, so because I'm above range 10,000, I have to do rough math. Remember, rough math, the equation for that is my VI, so positive 64. Here, let's go ahead and label this just so you can have your notes organized. So VI, positive 64 over range in thousands, which is 11.9. 64 divided by 11.9 gives us 5.38. Okay, now I need to place the decimal point to make the my 3 numbers as small as possible, but still remaining larger than the rough math. Okay, and if you need to refer to those rules, go ahead and refer to the slides of the cheat sheet, right? Place the decimal where it creates a value as small as possible, but larger than the rough math, okay? Small as possible, but larger than the rough math. So that would be 5.66. 5.66 expresses to 6, okay? So, and then it carries the same sign as the VI because we're low angle, right? So our site is positive 6. All right, good stuff. Let's go ahead and find our site for range 15,500. Remember, I don't need it for 12,300 because that's just my min time range line. Okay, so for 15,500, let's go ahead and just do this right here. Site at range 15,500. We say our VI was positive 24. Positive 24 VI. We said it was target above gun at range 15,500. VI of positive 24. Okay. Target above gun range 15,500. Okay, so 15,500, this is actually the kind of the range changeover point, because you see it's 1554. So 1554 is the last value listed on the bottom of the tagline there for 4 hotel. 15,500 is the first value above the tagline. So 15500 at VI24. Let's go ahead and extract our three numbers. So I extract 184. We'll call that 184. Three numbers are 184. Okay, so rough math is VI positive 24 divided by range in thousands, which gives us 1.56. Okay, place the decimal where it is, let me read it verbatim here. Place the decimal where it creates a value as small as possible but larger than the rough math. Smallest possible, larger than the rough math, puts it at 1.84, which expresses to positive 2. Carry the same sign as the VI for low angle sight. Okay, so sight is positive 2. All right, so now let's go ahead and solve for max range 17200. Let's go and get our notes started organized here. Sight at range 17200. I'm going to extract three numbers, and I'm eventually going to do rough math. We said our VI was positive 44 over range in thousands, which is 17.2. I'm just going to do it right now. 44 divided by 17.2 gives us 2.56. Okay, now I need to extract my three numbers. So target above gun, positive 44. So VI of positive 44. Target above gun, range 17200. 17200. Okay, so go ahead and extract our three numbers. I extract 378. 378. All right, make as small as possible while still remaining larger than the VI, which would be 3.78, which would then express to 4. Keeps the same sign as the VI because it's low angle, so positive 4. Go and clean up my scratch work here. Working fast and I'm starting to get sloppy, so let's just keep this nice and organized. Okay, so positive 4 for sight at range 17200. Okay. Remember, we had to do rough math because the diagram ranges were above 10,000, all right? Okay, so now we're moving past the solid black line, which means we're going to be using entry range only. Okay, so let's go ahead and extract a sticky note, cover up everything except our entry range. All right, so at entry range 11810, we need to go ahead and find the elevation. It's probably not going to be a listed value, so what are we going to have to do? We're going to have to interpolate. So extract our Alfa Romeo 2. Let's see your range 11800. All right, so we're going to be on page 412. Okay, so elevation at 11810. Okay, so 11810 is not a listed value, so we're going to have to interpolate 11810. But where does it fall between? It falls between 11800 on top and 11900 on bottom. Let's go ahead and set up our brackets. So what does it take to get from 11800 to 11810? That's 10. What does it take to get from 1800 to 11900? Is 100. So that's 10 over 100 equals x over. Trying to find it for 11810. But what is the elevation at 11800? It's 266.0 and 270.2 for range 11900. Okay, set up our brackets. 270.2 minus 266.0 gives us 4.2. Little over big equals little over big. Cross multiply, 4.2 times 10 divided by 100 gives us a value of x equals 0.42. Express at the x to 0.4. Let's add this up here. 266 plus 0.4 gives us 266.4. So 266.4. express as, well, real quick, let's sanity check. Does that fall between 266.0 and 270.2? Yes, it does. So that means that our elevation at range 11810 is 266.4. Express as I extract. As I extract 266.4, express it to 266. Okay, so now quadrant is the summation of elevation and sight. So that's 266 plus 6 gives us a quadrant of 272. Okay, quadrant 272 is a safety T value, so I'm going to go ahead and circle that. Quadrant of 272. Do I need a min time fuse setting at range 11900? No, I don't, right? Because my min range line for time is 12300, so I don't need that. But I do need it for VT. And my VT time fuse setting is a function of my time of flight. So we need to find time of flight at entry range 11810. Okay, so I can just use the left column that I calculated up here. So I'm just gonna pull that down. Make my brackets. Little over big equals, okay? So we're trying to find time of flight at 11810, but we do know it at 11800, right? Let's see here. At 11800, time of flight is 28.9. At 11900, time of flight is 29.3. Set up my brackets, little over big, so this is X. Top is always going to be X. And big, let's find our big bracket. 29.3 minus 28.9 gives us 0.4. Little over big equals little over big. Okay, so 0.4 times 10 divided by 100. Do that one more time. 0.4 times 10 divided by 100 gives us, yep, 0.04 expressed at the X. That expresses to 0.0. Okay, that sucks. 0.0. So 28.9 plus 0.0 gives us 28.9. Does that fall between 28.9 and 29.3? Yes, it does. So that means that our time of flight at range 11810 is 28.9. Okay. Okay, so now I take 28.9, add my 5.5 second safety buffer. So 28.9 plus 5.5 gives me 34.4. Express that up to the next whole second for VT, which is 3.5, and then add that 0.0 at the end for VT. Okay, so now I have 35.0 as my min VT time fuse setting. That is a safety T value, so I'm going to circle it. I always forget to circle my VTs initially. I also need drift, right? Because I need drift at my my most min, or my smallest minimum range, my largest maximum range. So I need it for range 1180 and 17090. Okay, so let's go ahead and solve for that. So drift at 11810. Just use the left-hand column that I previously set up. Little over big equals little over big. Okay, what is my drift at 11810? I don't know. What is my drift at 11800? 11800, my drift is 8.8. At 11900, it's 8.9. Okay, I can tell by looking at this is probably going to be 8.8, and it's going to express up to left 9 regardless, but let's just go ahead and get the rep in. Okay, so little over big equals little over big. Okay, so 8.9 minus 8.8 gives us 0.1, which is our big bracket here. So 0.1 multiplied times 10 divided by 100 gives us 0.01, which expresses to 0.0. That sucks. So that's 8.8. Does that fall between 8.8 and 8.9? Yes, it does. So that means that our drift at range 11810 is left 8.8. But remember, drift is always to the left, and it's always expressed to the nearest whole mil. So that ends up being left 9. is my least left, okay? All right, so next let's go ahead and find our data for entry range 12210. Do I need elevation or quadrant? No, I do not. I don't need time of flight, VT, or drift. All I need is my time fuse setting at this range. All right, that's all I need is my time fuse setting at range 12210. Okay. So 12210 is probably not a listed value. No, it's not. 12210, but it does fall between, let's see here, 12200 on top and 12300 on bottom. All right, so let's set up our brackets. So this is 10, right? Yep. And this is 100. So 10 over 100, so that's a little over big, equals. All right, so we're trying to find fuse setting at 12210. What is it for 12200? 12200 is 30.4. 12300 is 30.8. Okay, set up our little bracket. It's always going to be X. Set up our big bracket, which is going to be 0.4. Okay, so little over big equals little over big. Cross multiply. So it's 0.4 times 10 divided by 100 gives us 0.04, which expresses to 0.0. So that means 30.4 is our time fuse setting at range 12210. Sanity check, does it fall between these two values? Yes, it does. So our time fuse setting at range 12210 is 30.4. And that is a safety T value, so I'm going to go ahead and circle that. Okay, so now that I have that, let's move on to max range 15400. So max range 15400, what do I need? All I need is my my quadrant, right? That's all I need. I don't need a max time fuse setting. I don't need a max VT fuse setting, nor do I need drift, because I need drift at my overall max and my overall min ranges. Okay, so let's go ahead and find our elevation at 15400. 15400 is, oh, nice, 15400. Nice, that's probably a listed value, right? Because it is to the nearest 100 meters. Sweet, 15400, where are we at? Where are you at? We don't have to interpolate. All right, I'm on page 414 of the AR2, so entry range 15400 gives me elevation of 449.7. I express as I extract, so 449.7 expresses to 450. So now I take elevation 450, add my site of 2 to get quadrant of 452. Safety T value, I'm gonna circle it. Awesome. Okay. But now I do need my elevation, quadrant, and drift at my max range, overall max range of 17090. So let's find our elevation first, 17090. Okay, 17090. All right, is that a listed value? Probably not. 17090, but it does fall between 17000 on top and 17100 on the bottom. Okay, so go and make our brackets. So that's 90 and 100. So that's 90 over 100 equals. All right, we're trying to find elevation at 17090. We don't know what that is, but at 17000 it is 565.3, and at 17100 it is 573.9. Okay, set up our brackets. Little bracket is always X on the right side. 573.9 minus 565.3 gives us 8.6 as our big bracket on the right. So little over big equals little over big. 8.6 times 90 divided by 100 gives us 7.74, which expresses to 7.7. Always express the X to the value listed in the column on the right. Okay, so 7.7 plus 565.3 gives us 573.0. Sanity check, does that fall between these two values? Yes, it does. So 573.0 is going to be our elevation at range 17090. 573.0 express as I extract, so that goes to 573. So quadrant is the summation of elevation and sight, so 573 plus 4 gives me 577. Safety T value, I'm going to circle that value. Quadrant 577. All right, now let's find our drift at this range. So drift at range 17090. I can just use the left column that I calculated up here. Okay, I'm trying to find drift at 17090. What is it at 17,000? Drift is left 20.4. What is it at 17100? It is 20.7. Okay, go and set up our brackets. Little bracket on the right is always X. Big bracket. 20.7 minus 20.4 gives us 0.3. So 90 over 100 equals X over 0.3. Cross multiply 0.3 times 90 divided by 100 gives us 0.27. Express the X, so that expresses to 0.3. So 0.3 add to 0.4 gives us to 0.7. Does that fall between these two values? Yes, it does. So that means that our drift at 17090 is to 0.7. Okay, express as I extract. So 20.7 expresses to 2.1, left 2.1 because drift is always to the left. All right, now I have all my data for 4 square lot alpha, right? Because we're going to be solving for 6 square lot bravo down here. You know the drill by now. All right, so let's see here. So I have this. Let's go ahead and apply our drift. So looking at my leftmost deflection, so deflection 3500, which side is open for business? Right side is closed, left side is open, left is open, so least left. So that's left 9. 3509 is my deflection on the left. All right, what about deflection 3340? Which side is open for business, left or right? Right side is closed, left is open for business, so that's least left, so that's left 9. Deflection 3349. Goodness, it always gets crowded on these things. I never do this right. Okay, and then what about deflection 2800? Left side is closed, right side is open, least left, most right. So left 2.1, 2.821, and then circle it. Okay, so 2.821. So now we have our 3 deflections. We have all of our data for 4 square lot alpha. Let's go ahead and solve for our square weight correction. All right, but first things first. Let's go ahead and reference our rules for updating data for an increase in square weight. Okay, so we've been over this a couple of times. If you don't already have this recorded in your notes, go ahead and record it now. Right, min range with a positive value in column 19 is update. Min range with a negative value in column 19, we do not update. Max range with a positive value in column 19, we do not update. And max range with a negative value in column 19, we do update. Okay, this is for specifically an increase in square weight. Okay, so all right, so let's go ahead and record our diagram ranges. So 11900, that is a min range. Okay, 12300, that is a min range. 15500, that is a max range. And then 17200, that is a max range. All right, so starting with min range 11900. So let's look at 11900, column 19. So 11900 is a min range, and it has a negative value in column 19. So a minimum range with a negative value, I don't have to update. So I'm not worried about diagram range 11900, don't need it. All right, what about min range 12300? Min range 12300 has a negative value in column 19. As a min range with a negative value again, so I'm not worried about that. Max range of 15500. Okay, max range of 15500 here on page 415 has a negative value in column 19. So a max range with a negative value means I have to update. Okay, so I am going to need this one. So that is charge for hotel at alpha 1. So non-standard condition is 6 square. minus a standard condition of 4 square gives me an increase of 2 square, multiplied times a diagram range correction of -1.6. Okay, that's for range 15500. Okay, I'll do the math here in a second. Let's look at 17200. So 17200 is a max range and it has a negative value in column 19, so I also have to update this one. So same charge, same non-standard condition, same standard conditions, same delta in standard. The diagram range correction for 17200, however, is -22. Okay, so -22 is that range correction for 17200. Now let's go ahead and execute our math. So we're going to multiply 2 times 1.6. It's going to give me, what is that, -3.2. So -3.2, and remember, I have to add the raw range correction I first calculated up here for the change in muzzle velocity, right? So -3.2, so that's at diagram range 15500, plus -101.2 gives me, so that's 101.2 plus 3.2, gives me -133.2, which then expresses to the nearest 10, -130. Okay, so remember, I add the 2 raw values and then express at the end. All right, so next let's do 2 times 2. So that gives us -44 plus, what was the raw value up here? It was 107.6, -107.6. So that's 107.6 plus 44 gives me -151.6, which expresses to -150. All right, it starts to get super crowded down here when you have both a muzzle velocity correction and a square weight correction, which is why we're doing this for 777, so we get an extra rep at doing this, okay? All right, so let's go ahead and move these down here. So the first one is a max range, diagram range 15500, plus a range correction of -130, which gives me a total range, 15500 minus 130 gives me 15370 as my total range, times range K of 1.0000 gives me an entry range of 15370 at charge 4 hotel at 232 Alpha 1. Okay. Next is max range of 17200 plus a range correction of -150. So 17200 minus 150 gives me 17050. It's my total range multiplied times the same range K. Gives me an entry range of 17050 at the same charge 4 hotel. Okay, so now my VI and my sight is a function of diagram range, so I can just pull that down from up top. So we said VI and sight was +2.4 and +2 for range 15500, and for 17200 it's +4.4 for VI and +4 for sight. I'm crossing the solid black line, so I'm going to use entry range to the everything of the right of that line. So let's cover up everything else to the left of entry range. Now I need to find elevation at entry range 15370. Elevation at range 15370. Okay, so here on page 414, so 15370 is not a listed range, but it falls between 15300 and 15400. Set up our brackets. Okay, so that's 70 and 100. So 70, 100 equals trying to find elevation at 15370. Don't know what it is, but elevation at 15300 is 443.4. And 15400 is 449.7. Set up my brackets. Little bracket is always X on the right. 449.7 minus 443.4 gives us 6.3. So little over big equals little over big. Cross multiply. 6.3 times 70 divided by 100 gives us 4.14. Expressed at the x is 4.4. 4.4 plus 443.4 gives us 447.8. Sanity check, does that fall between these two values? Yes, it does. So our elevation at range 15370 is 447.8. Express as I extract, so 447.8 expresses to 448. Quadrant is a summation of elevation and sight, so 448 plus 2 gives us 450 as quadrant. Okay, it's a safety value, so I'm going to circle it. Do I need a min VT, or excuse me, a max VT fuse setting? No, I don't. Nor do I need a max time, nor do I need drift, because I always solve for drift up here. Okay, so next is entry range 17050. Need to find the same thing. Need to find quadrant. So elevation at 17050. It's probably not a listed value because that would be too easy, but it does fall between 17,000 and 17,100. Set up our brackets, 50 over 100. What are my values on the right? I don't know what it is for 17050, but for 17,000 it is 565.3. For 17,100 is 573.9. Set up our brackets. 573.9 minus 565.3 gives us 8.6. Little over big equals little over big. Cross multiply 8.6 times 50 divided by 100 gives us x equals 4.3 expressed at the x. It's already expressed to the 10th because the column on the right is expressed to the 10th. 4.3 plus 565.3 gives us 569.6. Sanity check, does that fall between these two values? Yes, it does. So our elevation at range 17050 is 569.6. Express this as I extract it. So 569.6 expresses to 570. Quadrant is a summation of elevation and sight. So 570 plus 4 gives us quadrant of 574, and then circle it. Okay, now that I have all of my data for 6 square lot Bravo, I can go ahead and construct my low angle safety T. So to do this, let's record our admin data. So location, firing point 166 at grid. 5309er, 3435, altitude 376, charge 4 hotel for 232 Alpha 1, Shell HE, Fuse PD, Fuse PD time and VT, and then azimuth of lay is 4600. Always start with our deflections, working from left to right. How many deflections do we have? 1, 2, 3. So I'm going to divide my deflection block into 3 separate parts. Starting on the far left, 3509. Always work from left to right with deflections. 3509, followed by 3349, followed by 2821. As a sanity check, I'm going to make sure that as I move from left to right, that my numbers are getting smaller, right? So 3509, 3349, 2821. Checks out. Okay, so now I need to go ahead and set this up. Let's do the easy ones first. Let's do min QE for HE, because we only had to solve for one min QE, right? So that's at range 11900. So min QE is 272. All right. Min time for HE, only had to solve for one min time. It's 30.4. And then min VT, only had to solve for one min VT time, and that's 35.0. Now, because we are, where's the race safety card? Because we are technically shooting 732 Alpha 2, you could express this up to 36.0 because 732 Alpha 2s can only be set to the even second, but it's not going to be counted wrong as if you leave it as 35.0. But technically speaking, 36.0 would be the more appropriate value to put. Okay, so now that I have that, I'm going to have to make an extra box up here because we had to solve for 2 max quadrants, right? So first one we're going to do is max quadrant for HE 4 square lot alpha. Okay, so what was my max quadrant on the left? So max quadrant on the left between deflection 3509 and 3349 is at diagram range 15500. So that would be 452. And then on the right, at range 17200 between deflection 3349 and deflection 2821. So that's 17200, that is 577. Okay, so I have that. So now let's find the associated ones with max quadrant HE 6 square lot Bravo. Okay. So on the left, so between deflection 3509 and 3349, I have range 15500, that's quadrant 450. And then on the right, I have the only other quadrant that's left, which is 574. And there it is, that is the safety T for low angle safety. Now we will move on to high angle. Okay, so remember for high angle, I can just use the basic safety diagram I calculated for low angle and just move that over, keeping in mind that on my range safety card, it states that the fuse time and high angle minimum range is 1 to 300 meters. Remember, the low angle and high angle min range line is typically not the same. Okay, so I just need to keep that in mind. So I'm not gonna have my min range at range 11900. It's gonna be range 12300. So let's go ahead and extract our straight edge. Go ahead and record our basic safety diagram. So it's range 1 to 300 with altitude 300, altitude 410. Well, let's go ahead and record our admin data. Firing point 166. 5309er 3435, altitude 376, charge 4 hotel 232 alpha 1, fuse PD. We only have to shoot fuse PD with high angle, azimuth of lay 4600, azimuth of lay 4600. Okay, go ahead and record our left dog leg. Give yourself some room this time. There we go. Okay, we said overall max range was 17200, altitude 420. And our dogleg range was 15500, altitude 400, left azimuth 4300, which converted to deflection 3500. I know I'm going to need to add drift here in a bit. Azimuth 4460, deflection 3340. I will need to add drift here in a bit, give myself a little bit more room. And then on the right side, I have azimuth 5000, deflection 2800. I'll have to add my drift here in a bit. Now my basic safety diagram is complete. We can move down here to our range corrections. So we're shooting charge 4 hotel, 232 alpha 1. Shell HE, fuse PD, projectile family Mike 795, which means we are going to be in the Alpha Romeo 2 TFT. Now let's find our total range corrections for our change in muzzle velocity, right? Because our diagram range corrections are going to be different for low angle than they are for high angle. So we have to resolve for all of these. So let's record our diagram ranges, starting with the smallest. So 11900, 12300, 15500, and 17200. Charge is for hotel 232 alpha 1. It's going to apply for all ranges. Non-standard condition is plus 4.0 meters per second. Applies for all ranges, minus a standard condition of 0 meters per second, standard for all ranges, which gives us an increase of 4.0 meters per second for all ranges. Okay, now we need to find our range corrections. We go to table Fox, for charge, for hotel, 232 alpha 1. Ensuring that we are in 232 alpha 1, not 232. Okay, for hotel, 232 alpha 1, looking for that rock star line. Because I'm shooting high angle, everything below the rock star line is going to be high angle. So what is my first range? It was 11900. So it looks like I'm going to be on page 420, correction 421 of the AR2. Diagram range 11900. All right, I have a increase of 4 meters per second, so I'm extracting data from column 11. So that'll be negative 20.0. It's going to extract all our values before we math. All right, diagram range 12300. Column 11 has a value of negative 21.2. I don't know why I recorded diagram range 11900. That's not even on our basic safety diagram. We don't need that. I don't know why I did that. Disregard. Okay, so sorry about that. So diagram range 12300 had a range correction of negative 21.2. Next diagram range is 15500. Get this out of the way here. All right, has a column 11 value of negative 27.4. Okay. Next we have range 17200. Negative 29.6 is our column 11 value. Negative 29.6. All right, let's extract our calculators. And we're going to do the math. So 4 multiplied times 21.2 gives us negative 84.8. Negative 84.8, which expresses to negative 80. Always record the raw value from your calculator, then express the nearest 10 meters. 27.4 multiplied times 4 meters per second gives us negative 109.6. Expresses to negative 110. All right, and then negative 29.6 times 4 gives us negative 118.4, which expresses to negative 120. Okay, remember that we have to find the total range correction for both low angle and high angle separately, because the range correction values here that we get from column 11 are going to be different for high angle than they are for low angle. And again, we didn't need to find it for diagram range 11900 because that's for that's just our low angle minimum range line, which we don't need here. Okay. So now that we have that, let's go ahead and bring these down here. Go ahead and record min diagram range 12300. Do I have a range correction? Yes. So plus negative 80 gives us a total range. Let's get that. 12300 minus 80 gives us 12220. That's a fun number. 12220 multiplied times range K of 1.0000 gives us entry range of 12220 at charge 4 hotel. Charge 4 is going to apply to all the charges, or all the ranges. All right, next we have a max range of 15500 plus a range correction of negative 110 gives us a total range. So that's 15500 minus 110 gives us a total range of 15390. Multiplied times range K gives us entry range of 15390 at charge 4. And then finally, the last one we have is also a max range of 17200 plus a range correction of negative 120. That's 17200 minus 120 gives us 17080 multiplied times 1.0000 gives us 17080 as our entry range. Okay, so now that we have that, let's go ahead and start calculating our site. So first things first, we need to calculate VI. VI for the min range of 12300. 12300, altitude is 410 minus the battery altitude of 376, gives us a VI of positive 34. Remembering to carry sign for VI always. All right, let's find VI for 15500. So that is target altitude of 400 minus battery altitude of 376, gives us a VI of positive 24. All right, 17200, altitude 420 minus battery altitude of 376 gives us a VI of positive 44. All right, next we need to find our angle of sight over 10. So let's go ahead and extract our scratch paper. So angle of sight for range 12300. All right, remember my equation for angle of sight equals VI, which is positive 34. VI over range in thousands, which is 12.3 times 1.0186. 34 divided by 12.3 multiplied times 1.0186 gives us 2.8. Carrying the same sign as the VI because angle of sight always has the same sign as the VI. So positive 2.8 divided by 10 gives us 0.28, which expresses to 0.3. That is positive 0.3. Okay, so my angle of sight over 10 is positive 0.3. Now let's extract our 10 mil sight factor for range 12300. I have a positive VI, so looking at my step action drill on my cheat sheet for sight that I always have handy, I'm going to be in the right column because I have a positive VI. So follow the step action drill below. Number one, if the 10 mil sight factor is listed on the high angle GFT, use that value. So let's check the high angle GFT. Okay, so extract the high angle GFT, ensuring that I'm on the correct side. I'm reading for charge 4 Hotel Mike 232 Alpha 1. And we said that our diagram range was 12300. So set off at 12300. Okay, looks like that my 10 mil sight factor is going to be listed on the high angle GFT, so I can use that value. If you haven't already done so, all of the ticks below the red 1 on your 10 mil sight factor line, each one of those represents 1/10. So it should go from right to left. You have the red number 1, followed by 0.9, 0.8, 0.7, 0.6. So that makes the manufacturer hairline close to 0.8. And remembering that 10 mil sight factor is always negative. Negative 0.8 is my 10 mil sight factor because it's listed on the high angle GFT. So we have that. Let's go ahead and multiply across. So that's 0.3 times negative 0.8 gives us negative 0.24, which expresses to 0. That's disappointing. Okay. Next, we have our max range of 15500. We need to find our angle of sight over 10. So high angle sight for range, said 15500. So angle of sight equals, I have a VI of positive 24. I have a range in thousands, which is 15.5 times 1.0186, which gives me 24 divided by 15.5 times 1.0186 gives me 1.5771869. So that's 1.6 positive 1.6, same sign as the VI. So now positive 1.6 divided by 10 gives us 0.16, which expresses to 0.2. Positive 0.2 is my angle of sight over 10. Okay, for the 10 mil sight factor, I'm going to refer to my step action drill for positive VI. If the 10 mil sight factor is listed on the high angle GFT, use that value. I have a feeling that it's going to be, so let's see. So we have range 15500. That is 1, 5, 1, 2, 3, 4, 5, 15500. Okay, so I set off range, and now I read here, knowing that each one of these ticks is 1/10, right? So that's 2, 2.1, 2.2, 2.3, 2.4, right on 2.5. Okay, so my 10 mil sight factor is negative 2.5. 10 mil sight factor is always negative. Okay, so 0.2 times negative 2.5 gives me negative 0.5, which artillery expresses to 0. Super disappointing. All right. Now, finally, for max range 17200, we need to find our high angle sight. High angle sight for range, we said that was 17200. Okay, so first things first, angle of sight equals my VI of positive 4.4 over range in thousands, which is 17.2 multiplied times 1.0186 gives me what? 4.4 divided by 17.2 multiplied times 1.0186 gives me 2.605 whatever, which expresses to 2.6, positive 2.6, carry the same sign as the VI. So positive 2.6 divided by 10, right? Because I'm trying to find my angle of sight over 10 for high angle sight. 2.6 divided by 10 gives me positive 0.26, which expresses to positive 0.3. So angle of sight over 10 is positive 0.3. Go and block that off. Pardon me. Okay. Now that I have that, I need to find my 10 mil sight factor for 17200. So I'm going to refer to my step action drill. I have a positive VI, right? Positive VI, positive 4.4. Follow step action drill below on the right side. If the 10 mil sight factor is listed on the high angle GFT, use that value. So set off range 17200. It's 172. So 17200. Looks like it is going to be listed on the high angle GFT. So that's between the red 5 and the red 6, there's one tick. So that's negative 5.5. So that looks like my manufacturer hairline is somewhere around negative 5.8 is what I'll call that, negative 5.8. Negative 5.8. So that's 0.3 times negative 5.8 gives us 1.74, which expresses to 2, specifically negative 2, because sight in high angle has the opposite sign as the VI, only for high angle. So if I have a VI of positive 4.4, I should have a sight of negative 2. Makes sense. So now I'm going to start finding my quadrants and my drifts. So I'm crossing the solid black line, which means everything to the right, I'm going to use entry range. I'm going to take a Post-it note, and I'm going to cover up everything to the left of entry range to make sure I don't accidentally extract data using diagram range. So the first one here is elevation at entry range 12220. So I need to find that. Let's extract our Alpha Romeo 2. And look for entry range 12220. So I'm going to be in table Fox, 12220. I'm going to be on page 420 of the AR2. And it's not a listed value, so I'm going to have to interpolate. I'm just going to start a new piece of scratch paper here on this side. Okay, so I'm trying to find elevation at range 12220. Okay, so I'm looking for 12220. It's not listed, but it does fall between 200 on the bottom and 12300 on the top. Remember to draw it out as it is listed in the table, okay? So we always interpolate top to bottom as listed in the table. So what does it take to get from 1220 to 12300? It takes 80 meters, and it takes 100 meters to get from 12200 to 12300. So that's 80 over 100 equals. All right, let's set up the right column. So we're looking for elevation at 12220, but I do know what it is for 12300, which is 1232.6, and at 12200, it is 1235.4. Set up our brackets. Little bracket is always X, top to bottom. And then we have 1235.4 minus 1232.6. Always use a calculator. Don't try to do the mental math. That's where most people make mistakes here in interpolating, is when they try to do mental math. Okay, so little over big equals little over big. So 2.8, cross multiply, 2.8 multiplied times 80 divided by 100 gives us 2.24. Express at the X, that expresses to 2.2. Okay, add it back in to 1232.6 plus 2.2 gives us 1234.8. Okay, sanity check. Does that fall between 1232.6 and 1235.4? Yes, it does. So 1234.8 is our elevation at range 12220. As I extract, I express. So 1234.8 expresses to 1235. Quadrant is summation of elevation in sight. So 1235 plus 0 is 1235. It's a safety T value, so I'm going to circle that. Next, I need my drift, because I always need drift at the overall min range and the overall max range, so I do need the drift here. I don't know what that is, so let's try and find it. So drift at range 12220. I can just use the left column I already set up here. So I'm going to pull that down, 12300, 12220, and 12200. That's 80. It's 100, so that's 80 over 100 equals. Let's set up the right side. Trying to find drift at 12220, but I do know what it is for 12300. 12300, it looks like it is left 121.7. And for 12200, it is left 124.7. Okay, set up brackets. It gives us 3.0. Okay, so little over big equals little over big. 3.0 multiplied times 80 divided by 100. Cross multiplying here gives us X equals 2.4. Express the X, it's already expressed. So 121.7 plus 2.4 gives us 124.1. Sanity check, does 124.1 fall between 121.7 and 124.7? Yes, it does. So our drift at range 12220 is 124.1. Express as I extract, so 124.1 expresses to 124, left 124, because drift is always to the left. Now for entry range 15390, that's a max range, so I do need my quadrant. So I need to find elevation at 15390. Entry range 15390. Okay, 15390. Is that a listed value? Probably not, because that would be too easy. 15390. Not a listed value, but it does fall between 15300 on the bottom and then 15400 on the top. Okay, what does it take to get from 15390 to 15400? It takes 10. What does it take to get from 15300 to 15400? It is 100. So 10 over 100 equals, and let's set up the right side. I don't know elevation for 15390, but I do know for 15400, which is 1120.9. And then 15300 is 1125.4. Set up our brackets, little and big. Let's find our big bracket value on the right side. 1125.4 minus 1120.9 gives us 4.5. 4.5, so little over big equals little over big. So 4.5 multiplied times 10 divided by 100, cross multiplying here, gives us x equals 0.45, which expresses to 0.4. That 5 artillery expresses that to 0.4, right? 1120.9 plus 0.4 gives us 1121.3. Sanity check, does that fall between these two values? Yes, it does. So 112.3 is our elevation at range, entry range 15390. As I extract, I express, so 1121.3 expresses to 1121. Now I need to find quadrant. Quadrant is the summation of elevation and sight. So quadrant is 1121, safety T value, and I circle that. Do I need drift at range 500? No, I do not, because I just need drift at my overall min and my overall max. So next, let's find our quadrant and drift for entry range 17080. So elevation at, we said 17080. Okay, 17080, is that a listed range? Probably not. That would be too easy. Let's see here. Be on page 416 of the AR2. 17080. All right, not a listed value, but it does fall between 17,000 and 17,100. All right, what does it take to get from 17080 to 17100? It takes 20. And then 100 there, so a little over big equals. And let's set up, we need elevation at 17080. I don't know what that is, but at 17,000, it is 1034.7. And then at 17100, it is 1028.0. Always record it as listed in the table. So let's find our brackets. Little is always X on the right side. 1034.7 minus 1028.0 gives us a big bracket value of 6.7. So little over big equals little over big. 20 multiplied times 6.7 divided by 100. Oop, no, that wasn't correct. 6.7 multiplied times 20 divided by 100. There we go. Equals X equals 1.34, which expresses to 1.3. Add that back in. 1.3 plus 1028 gives us 1029.3. Sanity check, does that fall between these two values? Yes, it does. So that means that our elevation at 17080 is 1029.3. As I extract, I express. 1029.3 expresses to 1029. All right, now I need to find quadrant. Quadrant is the summation of elevation and sight. So 1029 minus 2 gives us quadrant 1027, safety T value, circle it. Now I need to find my drift at 17080. Okay, I can just use the left-hand column I set up in my previous interpolation problem. 17080 falls between 17100 and 17,000. So that gives us 20 on this side, 100 on this side. So that's 20 over 100 equals, let's set up our brackets over here. I'm trying to find drift at 17080. Drift for 17100 is 56.6. And for 17,000, it is 57.6. Set up our brackets. The little bracket on the right side will always be X. Big bracket. Don't try to do mental math because that's how you're going to screw up. 57.6 minus 56.6 gives us 1. Little over big equals little over big. So 1 times 20 divided by 100 gives us X equals 0.2. Expressed at the X, it's already expressed to the value listed in the column on the right, which is to the 10th. So now I take 0.2, add it to 56.6, which gives me 56.8. Does that fall between these two values? Yes, it does. So my drift at range 17080 is left 56.8. Okay, as I extract, I express. 56.8 expresses to 5.7, left 5.7 because drift is always to the left. Now that I have all my values here, let's go ahead and add our drifts up to our deflections. So starting with the deflection on the left, deflection 3,500, which side is open for business? Right side is closed, left side is open. So least left. So least would be left 5.7. 3,557. Safety T value, I'm gonna go ahead and circle it. All right, next is over here, deflection 3340, which side is open? Left side is open, so 3340, least left. So left 5.7. So that gives us 3340 plus 5.7 gives us 3397. Safety value, circle it, 3397. And then finally over here, deflection 2800, which side is open? Right side is open. So that gives us left 124. So total deflection of 2924 on the right. Okay, so now that I have that, I've solved for 4 square lot alpha. I need to solve for 6 square lot Bravo. So we need to do a square weight correction down here. I'm gonna go ahead and record my ranges. So I have 1 min and 2 max ranges. So diagram range 1, 2, 300, diagram range 1, 5, 500, and max range 1, 7, 200. Okay, so let's refer to our rules for updating data for an increase in square weight, right? So if I have a min range line with positive value in column 1.9, I update, so on and so forth. We've been through this a couple times now. Okay, so I'm gonna refer to this. Let's look up our first range. So our first range is 1, 2, 300, high angle, because these values are gonna be different for low angle and high angle, right? So 1, 2, 300. It's gonna be on page 421. So that was value 1, 2, 300. Okay, so I have a min range line with a negative value in column 1.9. Min range line with a negative value in column, column 1.9. Yep, negative value. So that is min range with a negative value. I don't need to update, so I'm not worried about range 1, 2, 300. All right, what about max range 1, 5, 500? Max range 1, 5, 500 has a negative value. A max range with a negative value, I do have to update, okay? So I do have to update that one. Let's just go ahead and record all the data here. That's gonna be charge 4, hotel, alpha 1, right? 232 alpha 1, it's gonna apply for all charges. Non-standard condition is 6 square minus 4 square standard, gives us an increase of 2 square. Okay, what is my range correction? So my column 1.9 value for 1, 5, 500? Negative 30. Okay, now max range 1, 7, 200. So at max range 1, 7, 200, I have a negative value in column 1.9. So a max range with a negative value means I have to update. So 1, 7, 200 has a column 1.9 value of negative 30. Okay, so now that I have that, I can go ahead and math. So 2 multiplied times negative 30 gives me negative 60. But now I need to add my muzzle velocity range correction I got up here for range 1, 5, 500. So at range 1, 5, 500, what was that? That was negative 109.6. I always have to add the raw value. So negative 60 plus negative 109.6. What does that give me? So that's basically adding, so that's negative 60 minus 109.6. That's 109.6 plus 60 gives us negative 169.6, which expresses to negative 170. Now down here, so 2 times negative 30 again is negative 60. Adding the raw value that we had up here at diagram range 1, 7, 200, which is negative 118.4. So negative 60 minus 118.4 gives us negative 178.4, which then expresses to negative 180. Now that I have that, I can start computing my data down here. So let's move our AR2 out of the way so we can start moving things down. So that means I need a diagram range, a max range of 15500 plus a range correction of negative 170. So that's 15500 minus 170 gives us total range of 15330. Multiplied times range K of 1.0000 gives me entry range of 15330 at charge 4. That'll apply to all charges. All right, so next is my max range 17200 plus my range correction of negative 180. So 17200 minus 180 gives us 17020. Multiply times range K equals 17020 is my entry range. My VI angle of sight, 10 mil sight factor in sight is all the same as up here because it's a function of diagram range, right? So that is VI of positive 24. Angle of sight over 10 of positive 0.2. 10 mil sight factor of negative 2.5, which gives me a sight of 0. And then for 17200, it is VI of positive 44, angle of sight over 10 of positive 0.3, 10 mil sight factor of negative 5.8. Gives me a sight of negative 2. Okay, so now let's find our quadrants for both of these ranges. I don't need drift for either one because I just have to find drift up here, right? Okay, so let's go ahead and find those. Let me extract my scratch paper. So we need to find elevation at entry range. So we're using entry range, so I'm gonna put a sticky note here. 15330. So 15330. Refer to the Alfa Romeo 2. Going to be on page 418. All right, let's see here. So 15330 is not a listed value. Here we go, but it falls between 15300 and 15400. Okay, what does it take to get from 15330 to 15400? It takes 70 meters. So that's 70 over 100 equals, let's set up the right side. I need to find elevation at 15330. Elevation at 15300 is 1125.4. Elevation at 15400 is 1120.9. Set up my brackets. Little bracket is always X. Big bracket, 1125.4 minus 1120.9 gives me 4.5. So little over big equals little over big. So now we take 4.5 multiply times 70 divided by 100 gives us 3.15, which expresses to 3.2. Add it back in. 1120.9 plus 3.2 gives us 1124.1. Sanity check, does that fall between these two values? Yes, it does. So 1124.1 is our elevation at range 15330. Express as I extract, so 1124.1 expresses to 1124. Quadrant is a summation of elevation and sight, so 1124 plus 0 is 1124 for my quadrant. Okay, so now I need to find elevation at 17020. Okay, so let's turn back to page 416. So 17020 is not a listed range. So 10, but it does fall between 17,000 and 17,100. Okay, what does it take to get from 17020 to 17,100? That'd be 80. This is going to be 100. So that's 80 over 100 equals, I'm trying to find elevation at 17020. What is it for 17,000 is 1034.7. And then for 17,100 is 1028.0. Set up our brackets. 1034.7 minus 1028 gives us 6.7. So little over big equals little over big. So 6.7 multiplied times 80 divided by 100 gives us x equals 5.36, which expresses to 5.4. So let me go ahead and record that raw value and then express it. So that's 5.36, which expresses to 5.4. Okay, so now we add that back in. So 5.4 plus 1028 gives us 1033.4. Does that fall between these two values? Yes, it does. So our elevation at range 17020 is 1033.4. Express as I extract, so 1033.4 expresses to 1033. Quadrant is a summation of elevation and sight, so 1033 minus 2 gives us 1031. Safety T value, so I'm going to circle it. Now that I have all of my values, I can go ahead and construct my high angle safety T. So let's look here. Let's record our admin data. Altitude 376. Charge 4 hotel. 232 Alpha 1. Shell HE. Fuse PD. Azimuth lay 4600. Okay. Go ahead and how many? Let me cross these out real quick. So let's see here. So I'm going to cross out the Willy P's because this is an old format of a safety T. Okay, so how many max quadrants do I have? Max quadrant is associated with the min range line. So that's range 1, 2, 300. I only had to solve for one because I didn't have to do a square weight correction. So I'm only going to have one max quadrant for HE. So I'm going to go ahead and cut this in. You may have a different version of the safety computation worksheet. That's totally fine. It's not going to screw you up or anything. Just know that you only have one max quadrant for HE. And what was that? It was 1, 2, 3, 5. But I'm getting ahead of myself. I always work with deflections first, right? Do the deflections from left to right. Looks like we have 3 deflections. So we're going to separate those into 3 separate boxes. Deflection on the left is 3557, followed by deflection 3397, followed by deflection 2924. Making sure moving from left to right, deflection should be getting smaller, right? 3557, 3397, and then 2924. Yep, that checks out. Okay, so I had to solve for the max ranges. High angle max range is associated with min quadrant, so I'm going to have 2 blocks for min quadrant, right? So min quadrant HE 4 square lot alpha, and min quadrant HE 6 square lot bravo. All right, so let's do 4 square lot alpha first. So what was my quadrant associated with the range line between 3557 and 3397. So that's range 15500, right? So 15500 has a quadrant of 1121. All right, because I'm gonna have 2 quadrants on the other side because I have a dog leg. 1121, that leaves my other one of 1027. And then 15500 on the left, so that's 1124. For 6 square lot bravo, and then 1031 for, I'm sorry, correction, 6 square lot bravo. For HE 6 square lot bravo, right side is 1031. So there you have it. That is the high angle safety T for homework 5 for safety 1.